This meeting is being recorded.
In section 3.6, we will review how we can predict the equilibrium position of an acid-base reaction. And as you may recall, there are quantitative methods such as comparing pKa values of, in this case, our acid HA, and then our acid on the product side, HB. And we can also, through qualitative methods, compare the stability of the conjugate base to either acid A or acid B. So let's take a look and see how we can accomplish this. So in choosing reagents that will be able to react in the reaction that we're looking for, we might need to compare pKa values, for example, and if we specifically wanted to choose an acid that could protonate these molecules below, we would look up pKa values and determine that we would need an acid that would be stronger than the conjugate bases that were shown here. So we have four conjugate bases shown, or four deprotonated acids is another way of looking at that. And let's take a look here specifically at this species here, this acetate ion. So we can begin by drawing the acid-base reaction that would occur, and we're going to check and see if water will be a suitable reagent to protonate this acetate ion. So here's our acetate ion, as we saw on the last slide, and all the lone pairs are shown. So in this reaction here, we see the lone pair going out, grabbing that proton, and then the electrons that were involved in the OH bond of water have moved onto the oxygen over here in the hydroxide ion. So let's take a look and see if we could determine if this reaction would occur, if water is an okay reagent to protonate this acetate ion. So let's compare the bases on either side and see which is more stable. So we have our acetate, and then we have our hydroxide here. So we're going to utilize our skills from a previous section and use those four factors, the atom, resonance structures, induction, or orbital, with ARIO acronym, to determine which base is more stable. So we can see that due to resonance, so due to the R over here specifically, the acetate ion would be more stable. And then therefore the equilibrium, we would say, would favor this direction, the left direction. So, and because of that, water would not be a suitable proton source in this specific situation. We would need a stronger acid than water. So something like hydronium could be used. So let's take a look at this reaction, the reagents on a pKa table here, and see if we can make some determination. So the reaction that we were just looking at is with acetate here. So acetate is boxed in, that conjugate base on the right-hand side of our table, and we can see that acetic acid has a pKa around 4.75. So to protonate the conjugate base, we would need a stronger acid than this acetic acid, than 4.75. So that's why we said hydronium, with this value up here of negative 1.74, would be an okay solvent. So that's the determination there. Water, on the other hand, is down here at 15.7. So water would not be strong enough to protonate that acetate ion. Let's take a look at the other species. So I'm going to jump back to the slide here. So we've done acetate. Let's take a look at number 1, number 2, and number 3 here. So let's go back to our table, and we can see number 1 down here. Let's see, what was number 2? Number 2 is, Oh, is this it up here? Sorry. So here's number 2. And then what else do we see here? We see, oh, I'm sorry. We did, this is number 2, right? And we did this one down here, the acetate ion. So I'm just going to switch those. So 1, 2, and then 3 is also listed. Sorry, this is 3, and then this is 2. Okay, so 1 and 2 are below water, so they have higher pKa values, and therefore they will be weaker acids than water. So we could say that 2 of those species out of the 4, water would be okay to protonate. The third, number 3, we see the conjugate base in this square up top here, and note that it has a pKa value of -7.3. So we would need a very strong acid to protonate this conjugate base. So that's how you can determine if you're given these pKa values, if you have a suitable reagent to protonate the base that you're asked about.